This video will serve as the reteach for your periodic table test. If you're doing this ed puzzle, then you are preparing yourself to take the retest, meaning you made a 69% or below on the periodic table test. I'm going to briefly go over everything that was on the test, and if you have any more specific questions after doing the ed puzzle, please reach out to me via email or Schoology message. The test date for your retest will be announced later, if it has not already been announced already. First of all, your lab safety rules are expected to be known by now. You will have a few questions based off of this lab safety contract that you need to know. So please make sure that you review these. I'm not going to read through these because this is the third year that we've talked about these. So this is what your contract looks like. Please make sure that you take a look at it. It's in your binder. You can also find it in week 1 folder, found in the quarter 1 folder in Schoology. Lab tools and equipment. You are expected to know your lab tools and equipment very quickly. You can find this presentation in your week 1 folder as well. But these are the tools that you need to know: goggles, apron, tongs, beaker, graduated cylinder, flask, dropper, and test tube, as well as microscope, meter stick, electronic scale, spring scale, thermometer, stopwatch, hand lens, and triple beam balance. Last but not least, you have funnel, test tube rack, petri dish, and a Bunsen burner. To know what all these do, you need to take a look at this presentation. Again, this is in week 1 folder, found in your quarter 1 folder in Schoology. You can also pause this video to take a look at these as well. Lab scenarios to help you with these are found in this particular presentation as well. If you would like to take a look at those, then the answers are with it as well. Checkpoint questions to help you with that. And you can find the answers throughout this presentation. Okay, getting into the metric system. Remember that we use the metric system in science, even though we don't use it in the United States. This is the metric system where we use kilo, hecto, deca, deci, centi, and milli, where kilo is going to represent 1,000, hecto 100, deca 10, deci 1/10, centi 1/100, and milli 1/1000th. We can use a ruler or a metric stick to measure length or distance. An example of a unit for length or distance will be meters. Also, we can transfer between units based on how many meters we have by using kilometers. Like if we have a lot of meters, it might be easier to use kilometers. Kilometer represents 1,000 meters. Also, if we have a lot smaller numbers, like they're definitely not meeting the 1 meter mark, then we could also use centimeters. 100 centimeters is the same thing as 1 meter. This is how you measure using a ruler. You can pause and take a look at this if you need to. Mass is going to be the amount of matter in an object. We use scales to find the mass of objects. When using really big objects, we can use units such as kilogram, which is 1,000 grams. When using units of smaller numbers, we could use milligrams, which is the same thing as 1,000 grams. This is using a triple beam balance, which you will not be required to know for your test. Volume is the amount of space an object takes up, and we use a graduated cylinder to measure the volume of liquids. Liters is typically what we use, but if we're using really small numbers and they don't equal a liter, we can always use milliliters, which is the same thing 1,000 milliliters is the same thing as 1 liter. Always use the meniscus or the bottom of the curve when using a graduated cylinder. And when using temperature, we use Celsius. Again, if you need to stop and pause through these, you're more than welcome to, or you can find these presentations in week 1's folder. Now, getting into the main parts of this unit, we talked about atoms and the parts of an atom. We did briefly talk about the scientist. You can read through these if you need to, pause as you need to, or go find the presentation in quarter 1 folder. The atomic theory states that all elements are composed of atoms and cannot be divided or destroyed. Atoms of the same element are exactly alike. Atoms of different elements are different. The atoms of 2 or more elements can join together to form compounds. There's your overview of the scientist. All right, parts of an atom. Remember that we have 2 locations. We have the nucleus and we have the electron cloud. The nucleus is going to be the center of the atom. The electron cloud are going to be the rings around the nucleus. The subatomic particles that are in an atom are the protons, the neutrons, and electrons. Positive charged particles are in the central of the atom. Also, our neutrally charged particles are there, the protons and the neutrons. So most of the mass is going to be inside the nucleus simply because 2 out of the 3 particles are going to be in the nucleus of the atom. Protons are positive charged where neutrons have no charge, which is why our nucleus is always going to be a positive charged area of the atom. Around the nucleus, we have the electrons, which are negatively charged. They are found in the electron cloud and arranged on levels, which we called energy levels, that surround the nucleus. The very lowest level, the level closest to the nucleus, can only hold 2 electrons, whereas everything else after it can hold more. Atoms are always going to be considered neutral at first, where they have the same number of electrons as they do protons. If they have the same number of negative and positive charges, then they have a neutral overall charge. When looking at the periodic table, we color-coded it for our notes. I did go through, this is the key for your color coding the periodic table. We have 5 families that you need to know. Group 1 is the alkali metals. Group 2 are the alkaline earth metals, and the transition metals are group 3 through 12. The halogens are group 17. The noble gases are group 18. So knowing those is something you will have to know for your test. Also, the atomic symbol is going to be the number of protons and electrons. So silicone, for example, has 14 electrons and 14 protons. The symbol is always going to be the abbreviation of the name of the atom. The mass is going to be the number of protons plus the neutrons, the sum of them. Group numbers are the column numbers. If you drop the 1 off of group 13, that means it has 3 valence electrons. If you drop the 1 off of group 14, it has 4, and so on. Those numbers are also listed down here with the group numbers. Since group 1 and 2 are single numbers, then they are only going to have that number of valence. So the group number 1 will have 1 valence. Group number 2 will have 2. Remember that valence electrons are the number of electrons in the outermost energy level. Period numbers go down the side here. They're the rows from left to right, and they tell us how many energy levels each atom has. We talked about ions and isotopes. Ions are when the electron number is different in an atom. So a lot of times atoms try to become completely full in their outer energy level. And in order to do that, they are going to give away or take on more electrons. To be full in the outer energy level, it needs to have 8 electrons. The goal is to have 8, otherwise, it is not a happy atom. So, an example, magnesium has 12 protons and 12 electrons. We know that because of because of the proton number 12. Remember, proton numbers is the identifier of the atom. Whenever magnesium, when you look at the valence electron number, it's 2 because of the group number 2. Remember, it wants to have 8. Anything in groups 1, 2, or 13 are going to lose their valence electrons in order to become stable. In this case, magnesium will lose its 2 electrons. When it does that, it leaves it with an overall positive 2 charge because now it has 2 protons that are not going to cancel out because of the loss of those 2 negative charges. Sodium atoms have 11 protons and 11 electrons with a net charge of 0. If the sodium ion has 10 electrons, meaning it gave away its 1 valence, what is the net charge of the ion? Well, if it has 11 positive charges and 10 negative charges, that leaves it an overall positive 1. And the chemical symbol for that ion would be +1. Beryllium atoms have 2 protons and 2 electrons, which makes it, 4 protons and 4 electrons, which makes it a net charge of 0. If beryllium gets rid of its 2 valence electrons, then its overall net charge will be a positive 2 because it has 4 positives and 2 negatives. The chemical symbol for that will be positive 2. Isotopes are when atoms lose or gain neutrons instead of electrons, and this affects the overall mass of the atom. For example, if hydrogen 1 has 1 proton and 1 electron and 0 neutrons, the overall mass of hydrogen is going to be 1 proton plus 0 neutrons, which makes the mass 1. So we would call this hydrogen 1. The isotope of hydrogen 1 would be hydrogen 2, where it has 1 proton and 1 neutron, which the mass will now be 2 because it has an extra neutron that we didn't have in the previous hydrogen 1. Hydrogen 3 is protons 1 and neutrons 2. Add those together to get the mass of 3. Most of the time you'll see these written as the element written out, and then the mass written beside it. So here we have 207 at the top and 82 at the bottom. 207 is going to be our mass number, 82 being the atomic number. Last but not least, our Bohr and our Lewis structures. Y'all learned how to draw these when we went through this presentation. For a Bohr diagram, we are always going to use all of the electrons. So to draw a Bohr diagram, you have to have the number of electrons. For example, lithium is going to have 3 total electrons. When we draw this, we're going to draw the number of energy levels, and the first level itself can only hold 2 electrons. So once we draw it, we're going to place 2 electrons on it. And at that point, that level is full. So now we're going to have to draw one more energy level, which is where we add our other electron. And when we do that, this is what our Bohr diagram for lithium looks like. All of the electrons and the number of energy levels there. If we were to draw oxygen, it would be draw the first energy level and add 2 of the electrons. Oxygen is going to have a total of 8. So 2 on the first level, and the rest of them are going to go on the second level because there's 6 left. The second, third, fourth, and so on levels can hold 8 electrons. So this would be 2 electrons on the first level and 6 on the second level. And that's all the electrons we have for oxygen. So we will not fill up the second level up to 8. We'll stop when we're done. Sodium, you can see, has 2 on the first level, and it ended up filling up the second level with 8 total electrons before we had to move on to the next level. So sodium has an atomic number of 11, which means that we have to put 11 electrons here. So with 2 filling up the first level, 8 filling up the second level, that would leave our last one to go on the third level. 2, 8, and 1 makes a total of 11. Lewis dot structures are going to use the valence electrons instead of all of the electrons. So first we'll draw the symbol, and then we use the valence number of electrons. So for oxygen down here at the bottom, oxygen is in group 16. So drop the 1, it will have 6 valence electrons. So you'll place 6 electrons around the symbol O. Remember that if you need to pause here and read the screens, you can, or you can go into the folder where we had this presentation. You can find that folder in the Quarter 1 folder in Schoology. So for example, boron, you would draw the symbol. It's in group 13, so drop the 1, and that would be 3 valence electrons. Okay, and that is your review here of everything that we've done for this unit. You will be answering the questions as this video has gone through, and once I see that you have submitted this ed puzzle, then I will know that you are ready for your retest. Your retest will be on the date that I gave you. So if this ed puzzle is done, I will assume that you are wanting to take the retest. If the ed puzzle is not done, I will assume that you are choosing not to take your retest. Let me know if you have any questions.